Several people had requested I do a brief demonstration of my water source heat pump controller. I am not a hardware designer. I'm not an electronics engineer. Everything you see here, I have just kind of learned by trial and error, figured out what worked, what didn't work. This is version 3. The first 2 did not work so well, but I have not found anything wrong with this one as far as it failing, dropping a call or something like that. It's been very reliable. All of the tests that I've put it through, it's worked. So anyways, let's kind of go through this. This is our 24-volt AC input. This is our inputs from our thermostat. And then we have our outputs, like fan, compressor, reversing valve, isolation valve if you're going to use one, high pressure switch, low pressure, freestat, condensate, all your safeties here on the end. This is all one plug. Plug it in. This is plug in, and then we have our common and ground here, plug in. So this board can be changed out very quickly. Another thing is I like to use sockets with my ICs. So if your 328P goes bad, pop a new one in. They're about $8. Make sure it's got the bootloader on it. Plug in your FTDI programmer, program it, you're ready to go. So instead of replacing a board, you can just replace an $8 IC, or maybe your ULN 2003 went bad. Same thing, for a few bucks, you can fix that. So I don't have this isolated with optocouplers. I tried to do that on one version, and I wasn't successful getting my power isolated in an affordable manner. I wanted this to be cheap and easy to build. The other water source heat pump controllers, like the CXM controller, the CXM2, I'm not seeing isolation on those. The Daikin water source heat pump controller, I'm not seeing isolation on that either. So I said, well, why should I go through this headache of getting everything isolated when nobody else in the field is isolating theirs? This seems to work fine. So I just went with it. The dip switches. Dip switch number 1 is reversing valve. If it's in the up position, it's going to energize the reversing valve on a call for cooling. So if you put in a Daikin, it needs to call for reversing valve and heat. Then you just move this dip switch down. That's all you have to do. You don't have to go into here and reprogram anything. Dip switch number 2 is the freeze stat. So for troubleshooting purposes, if you want to disable the freeze stat, instead of jumping it out like we often do in the field, just turn that switch off and it won't look for it anymore. Same with the condensate protection. If you just want to eliminate that as a possibility of why this thing's faulting, dip switch number 3. Just turn that off if you don't want to use condensate protection. Condensate protection selection. So as you know, some water source heat pumps, the condensate pan has a switch, like sometimes it's a reed switch with a little float with a magnet in it. You see those in a lot of trains. Sometimes it's an actual float with a switch. So this will look for a switch if number 4 is in the down position. It's going to look for this safety here to be a closed circuit from this one to this one, from this condensate terminal to this one, looking for a closed circuit. When that circuit opens, then it's going to fault on a condensate trip if number 4 is pushed down. If number 4 is pushed up, it's going to be using the condensate sensor. And what it's doing is it's looking for a path from here to ground. And if it finds a path from here to ground less than 1 mega ohm, which even though condensate, a lot of people don't know this, but condensate has a lot lower conductivity than tap water, but it's still well above that threshold. So you're going to have no problem sensing condensate from here. When this is number 4 is in the on position, it's going to be looking for this type of condensate safety. And then number 5 is just if you want to use an isolation valve, control the isolation valve from the board, this being the on position. If you don't want it control from the board, if you're not going to use this, you don't need this relay banging on and off, then you just turn number 5 to the off position. You can actually use this isolation valve relay if you're not using ISO. You can use it as just an auxiliary relay to control something else you might want, like just some sort of universal output, and you can change that in the programming. The programming is completely open source, So, you know, make all the changes you want for whatever application you may be having. So let's turn this to the cool. We'll leave the fan in auto. Reversing valve should come on first. Then our isolation valve is going to start opening up, and then our fan is going to come on. This timeout here is in the thermostat. So the thermostat is about to send the call for cooling to the board. There we go. Isolation valve, you can hear it opening up. Our fan's on. Now I have the compressor timeout shortened just for the purposes of a demo, but you might want, like, you know, like maybe a 2 or 3 minute compressor timeout depending on the size of the unit. It's going to time out, and then I'm going to show you what happens when we trip one of these safeties. So I think it's important for any board with a microcontroller to give you specific fault indicators, like actually tell you what tripped. You know, if you have a board that you sell for several $100s and it can't tell me whether it was the high pressure switch, whether it was the low pressure switch, or whether it was the high discharge pipe temperature, you know, I think that's ridiculous. That's ridiculous. Okay, so our compressor came on. So we're running, we're cooling, and we're gonna trip a safety. We'll just pick one. Let's wiggle this off right here. Open the circuit. Compressor is locked out. We got a flash code. 1, 2, 3, 4, 4. So we look down here. 4 flashes, freeze stat. Now, you don't have to power this off. We don't have to kill power to the transformer. We don't even have to unplug this to reset this. I put a button right here. You want to reset it? Push a reset button. Everything will go through, time out, and cycle. So here any second now, our reversing valve is going to come on. Oh, well, actually it's not. I have to put the safety back on. Duh, close this. It's already locked out again. Okay, reset. Okay, then our compressor begins its timeout again. So that's pretty much everything. If you have any questions, leave a comment. Thanks for watching. Thanks for following.